Hello and welcome back. I know you guys have had a wonderful J term, but I thought it'd be good for us to review what we've been working on in class, specifically the laws of exponents and a few additional things. So I want you to just kind of get your brain around the math again. So let's talk about those laws of exponents. Let's see which one we want to start working with first. So there's lots of properties that we talked about. And so the first one we're going to talk about, as the spinner says, is negative exponents. Now, let's remember that a negative exponent does not make a number negative. A negative exponent does not make a number negative. And we looked at those patterns of negative exponents and we came up with some rules that we saw based on those patterns. But if we have like x raised to the negative 2 power, then we can rewrite that as with a positive exponent as 1 all over x to the 2. You guys all said bring it downstairs, but not forgetting to leave a placeholder 1 in the numerator. As well as if I give you, 2 all over x to the negative 3 power. Now remember, this is the only thing that's going to get moved, whatever's touching that negative exponent. So that negative exponent, if we wanted to make it positive, we'd bring it up, bring it next to the 2, and it would become 2x to the 3. So, and then the one that we spent a lot of time talking about would be if I gave you like x squared all over y cubed, a fraction raised to a negative exponent. That pattern we saw, we found that it was easier if we first flipped the fraction instead of bringing that exponent through and making the exponent positive, because that was what was happening if we went through all those rules of like distributing that exponent through. Now it's power raised to a power, and so we multiply the exponents here and here. So y to the 9th over x to the 6th. So fraction raised to a negative exponent, flip the fraction, make the exponent positive. All right, so going back to those laws of negative exponent, where should we go next? We should go to multiplying exponents. Okay, so that's where we started with multiplying powers. If I give you x cubed times x to the 6th times x to the 2nd, we know that power times a power, we add those exponents high. So power times a power, add them high. So 3 plus 6 plus 2 gives me x to the 11. Okay, now remember, if I give you powers with numbers, we do not change the number. As much as we want to multiply the 2's, we do not. This would become 2 to the 11th power. All right, so just keep that in mind. Okay, going back to the laws of exponents, let's see where the spinner has us going next. The spinner has us going to, dividing, one of my favorites, dividing exponents. Okay, so dividing powers. Now remember, one of the rules that we came up with when we were doing this earlier was bring the smaller exponent to the larger wherever it is in the fraction and subtract. So this 2 is going to come up. We have x to the 5 minus 2, which gives me x to the 3. And the fraction kind of went away, but we got to be careful. If I gave you that same thing where the 2 was in the numerator, the smaller was in the numerator, bring the smaller to the larger and subtract. So that would give me 1 all over x to the 5 minus 2. So be careful when we're doing that, so that we make sure we leave that placeholder 1. So that would give me 1 all over x cubed. Now, one thing I do want to mention is if those were negative exponents, since we talked about, say I give you x to the negative 5 over x to the negative 2. Well, smaller to the larger and subtract. Negative 5 is actually smaller than negative 2. So that's going to become 1 all over x to the negative 2 minus negative 5. And that negative here becomes a plus. So I get 1 all over negative 2 plus 5, which would give me x to the 3 power. All right, I think a couple more that we have to do would be power raised to a power. Now this is different. Remember, we did like x cubed raised to the 2 power, and we can get really tricked up here. Power raised to a power, we multiply the exponents. So this becomes x to the 6th. And the reason that was, if you remember, was because it means this. This means that we have 2 of them, okay? Which means that we would add the powers, giving us x to the 6th. So we don't want to forget that rule, okay? All right, and then the last thing we learned before you left was how do we use this? We use these laws of exponents to solve equations, okay? Now, in this case, we have an equation. Those were all expressions because there was no equal signs, but now we have an equation and we're trying to find the value of x. To do that, we have to use multiple properties. If we want to solve, we need a single exponent equaling a single exponent. But remember, these numbers have to be exactly the same. So we can work backwards to do that. We need to make the 8 look like a 2, and we can rewrite 8 using a power, making it the power of 2 by writing it as 2 cubed. Now, that would still be raised to the x minus 3. Now, we're getting closer to having the bases the same. So then, we would have power to a power, so we have to multiply the exponents. Now, x minus 3 is an expression, so think of it as having parentheses around it. So now we have to distribute the 3, giving us 2 to the 3x minus 9. Now, since those bases are the same, we can cancel them and get the equation 2x plus 1 equals 3x minus 9. And then solve for x. So subtract 2 to both sides, 2x, and then add 9. So we get that x equals 10. So that's how we can use those powers of exponents to help, making the bases the same and then solving. All right, what else did we do before we left? We learned to multiply binomials. Most of you felt really comfortable multiplying binomials by using the distributive property. I know some of you called it FOIL, but I want to make sure you realize it's distributing. So that 2x, we have to multiply the 2x to the 3x and the 2x to the negative 2. So that would give me 6x squared minus 4x. And then we have to multiply the 1 to the 3x and the 1 to the negative 2, which would give me a positive 3x and a negative 2. All right, now we've done the multiplication. Now we've got to combine those like terms. Combining like term means add. Remember, combine like terms means add. CLTA. So we get 6x squared minus x minus 2. Now we did use an area model here, which is totally fine as well. We moved on to multiplying polynomials, and all of us saw the value in using an area model. And by that I mean making a rectangle and breaking it into parts. In this case, we would break it into 3 because this is a trinomial and has 3 terms, by 2 because this is a binomial because it has 2 terms. So I put x and 2, x squared, a negative 3x, and a negative 6. Now, because it's area, we multiply. Each box is a rectangle, so we multiply the terms. So x, that would give me x cubed minus 3x squared minus 6x. The bottom terms, we have 2x times x squared, which gives me 2x squared minus 6x, and then minus 12. All right, now we've done the multiplication, so now we have to combine the like terms, so we have to add the like terms. So we're going to add these guys, and we're going to add these guys, rewriting our polynomial as x cubed. Combine these two, it's going to give me a negative x squared. Combine these two, that's going to give me negative 12x, and then we have minus 12. All right, guys, so the last thing I want to talk about is how we used all of this. We used all of this to solve equations with polynomials. Okay, so take a quick breath and look at this. So we have binomial equaling binomial, and we need to make them simplify. We need to simplify each side so we can solve. All right, so we are going to multiply x times x and x times negative 5. That's going to give me x squared minus 5x. Then we're going to deal with that 2, 2x, and negative 5. That's going to give me positive 2x and a negative 10. We're going to combine the like terms by adding. So we get x squared minus 3x minus 10. Now remember, x squared and x are not like terms, so we can't add them. All right, on the other side, we're going to do the same thing. X times x, it's going to give me x squared. X times negative 3, it's going to give me negative 3x. Negative 1 times x is going to give me negative x. And negative 1 times negative 3 gives me a positive 3. All right, and we're going to combine those like terms. X and x are like terms. And we get negative 4x plus 3. All right, so now we have an equation that we can solve. Now, we have multiple things that are happening here. We have x squared on both sides. So watch what happens when I subtract that to both sides. It actually gets eliminated. It gets canceled out. And now we're left with an equation that we do know how to solve, because you actually don't know how to solve an equation with x squared in it yet. So that's why it was really nice that it canceled out for us. All right, so we bring the smaller to the larger. So I'm going to bring 4x over to give me a positive x. I'm going to add 10 as well. And that's going to give me x equals 13. All right, guys, so that's a quick review of everything that we were doing the last couple of weeks prior to J-term. I hope you found that helpful so that tomorrow we can do some practice and move on to some really cool new stuff, some more word problems and literal equations. But have a great weekend. Bye.